Hi ladies, you are my favorite students, and today we are going to figure out how to add two vectors. So we are going to add this vector. Oh boy, here we go. We're going to add this vector and this vector. So let's start with the first one, that's 10 meters south, 30 degrees east. Okay, so I'm going to draw it out. So here's south, and then it's east, and the angle between them is 30. So this is how you draw it. Okay. So it says south, and then east, and the angle between them is 30 degrees. It says the hypotenuse is 10 meters. Okay. Now the other one is 10 meters southwest. So south, and then west. And if it says southwest, you know the angle is what? 45. So that angle is 45 degrees. Okay? Now, we're going to add them. So last time we talked about the vector component method, which means you add up the x's of each vector and the y's of each vector separately. So let's say I call this vector 1, call this one vector 2. I'm going to look for my x component for vector 1 and my y component for vector 2. Now, the way it works is the x component for vector 1 is the opposite side. So the formula is going to be sine theta times my hypotenuse, because it's the opposite side. If we notice, the y component is the adjacent side. So it's going to be cosine theta times my hypotenuse. For vector 2, it's actually the same because the x is the opposite side and the y is the adjacent side. It's actually the same formula. So x is going to be sine theta times my hypotenuse, and y is going to be cosine theta times my hypotenuse. Okay? So let's figure these out. So if I look at the first vector, so it says x equals sine 30 times my hypotenuse, which is 10. So that's going to give me, for vector 1, what's that going to give me? So sine 30 times 10 is 5. Okay? My y component is going to be cosine 30 times 10. That should give me 8.7. Okay? But next step is to look at the directions. So for instance, the x component is pointing east or west? East. So that's going to be positive, and my y component is pointing north or south. So that will be negative. So now we can look at the second vector, because we're going to add the second vector. And the second vector is x equals sine theta times my hypotenuse. So sine 45 times 10, and that's going to be 7.1. And because it's 45 degrees, the y is going to give you the exact same answer. So it's also going to be 7.1 because cosine 45, sine 45 are the same. Now, vector 2, the x is pointing east or west? West. And the y component is pointing south. Okay, so that's negative. Now what you do is you add them up. So if we add them up, let's use this bright yellow. 5 and negative 7.1 give you negative 2.1. And negative 8.7 and negative 7.1 give you negative 15.8. So if you were to actually take these two vectors and add them up, so if I was to add this vector here, this one, okay, and this one, if I was to add those two together, it probably would look something like this. like this and like this. So it looks like it's pointing definitely south. Okay, but I'm not drawing this to scale, so I know for sure that's going to be pointing south. And I can see by my y component that it definitely is pointing south. Now, because it's not drawn to scale, I can't really tell if it's pointing east or west, but according to my vector component method, it's actually pointing west. So this is going to allow us now to figure out the length of this vector, which is going to be our displacement, and also the angle. So it says that the vector is pointing west, so that's 2.1, and it's pointing south. So it looks like this, and that's 15.8. All right, so this is going to be my displacement. Okay, so let's finish it off on this side. So what is my displacement then? What could I use? Well, I'm going to use sum of the squares, right? So my displacement is going to be the sum of 2.1 squared and 15.8 squared. Obviously, the negative signs are irrelevant because that's just my direction. That's not going to change my displacement. So what is my displacement? So this is my hypotenuse. What is it? 15.9? Okay, so it's 15.9. So there's my displacement, 15.9. My angle, okay, well, I could do opposite over adjacent. So remember, tan theta is opposite over adjacent. So my opposite side is 15.8. My adjacent side is 2.1. So if I take the inverse tan of that, then I will get my angle. And it looks like it's a pretty big angle. Obviously not 90, but it's more than 45. What is it? 82.4? Okay, so 82.4 degrees. So what we could say then is our displacement. Displacement is 15.9 meters. West, 82.4 degrees south. Okay? All right? All right, let me end there.